All right, welcome to another geometry session, and we will be looking at the geometry of 2D shapes. And in our first lesson, we'd like to quickly recap properties of triangles, quadrilaterals, and lines very quickly and have a few exercises done. All right, the first thing I want to look at will be the types of triangles. Types of triangles. All right, triangles can be classified in terms of 1, the angles, and number 2, the length of the sides. We all remember that a triangle, the word tri means 3. So a triangle has 3 sides. All right, let's look at the first one in terms of angles. In terms of angles. All right, the first one we would consider quickly is an acute. Number 1, acute angle triangle. All right, an acute angle triangle. Okay, let's make this white. All right, an acute angled triangle. An acute angle triangle. All right. In terms of angles, first let's understand that here the sum of angles in a triangle. Let's quickly do this. The sum of angles in a triangle is 180 degrees. All right, so when we come back here and look at an acute triangle, what would be the property of an acute triangle? All angles are smaller than 90 degrees, but add up to 180 degrees. So if I have this, let's label this A, B, and C. I could then have this as 60. All right, I could then have this as 80. All right, so 60 plus 80, or I have 140. So this must then be 40 degrees. All right, so all the angles are smaller than 90 degrees. Very, very important. All the angles are smaller. So the word acute actually means smaller than 90. Acute means less than 90 degrees. All right, that's the first type of triangle in terms of angles. Number 2, obtuse. Okay, obtuse angle triangle. Here we can then say that the largest angle is greater than 90 degrees. All right. The largest angle is greater than 90 degrees. Okay. I'm going to try to reshape this. Okay, I may have to just draw this quickly. The largest angle should be greater than 90 degrees. All right, so I can then have something like this. All right, and if we label, ABC. All right. I can then call this 120 degrees greater than 90 degrees. All right. And this could probably be, I've got 60 left. I can just distribute 20 and then 40 degrees. All right. So the largest angle here is greater. So when we say obtuse, obtuse means something greater than 90 degrees. All right. Number 3 in terms of angles will be a right angle. Don't forget, all of these triangles would have one common property, that the sum of the angles would be equal to what? 180. Right angle triangle. All right. One of the angles is equal to 90 degrees. So let's have awesome. And in representing that, I'm going to use a yellow to show that angle. When we see that square-like thing there, it means that angle is 90 degrees. So we have A, B, C. I could then have this to be 30 and this will be 60. Everything must just give me 180 degrees. All right, so we call that a right angle triangle there. So these are the 3 types of triangle we have in terms of angles. All right, let's quickly run through and look at what we have in terms of sides. Okay, in terms of length, I'm going to divide this board into 3. So I have all my diagrams in one page. All right, the first one we will talk about would be a scaling triangle. Then we'll talk about an isosceles triangle. And then here we'll talk about an equilateral triangle. All right, a scaling. All 3 sides are different in length. All 3 sides are different in length. So you would have, remember, I'm just doing a freehand sketch. Okay, and if they are different, this is what I will then use to show it. The length here, 1, 2. So they are not equal at all. All right, so the 3 sides are not equal. Now, when I talk about isosceles, I'm going to say 2 sides. All right, we're going to call them 2 opposite sides. 2 opposite sides are equal. And the angles opposite the equal sides are also what? Equal. All right. 2 opposite sides, 2 sides are equal rather. Let's use the word 2 sides are equal. And the angles opposite the equal sides are also what? Equal. So I'll have something that looks like this. And to show that 2 sides are equal, I can then do that. All right. So if I have A, B, C, and to show that the angles are equal, I would just use a single dot there and a dot here. All right. To show that these angles are different, I can use 1 dot, 2 here, to show that all these angles are different. Right. But in this case, 2 angles are equal. This is the different one. All right. But they must all sum up to 180 degrees. And the third one, equilateral. The word equi simply means equal. All right, equal means equal. So we have 3 sides. All 3 sides are equal, and all 3 angles, also equal. All right, I could just get a shape there. Okay, looks fairly equal, and to show that they're equal, I will do that, and the angles I'll represent with 1 dot, 1 dot, 1 dot. Oh, by the way, it's okay to actually say that the angles here are 60 degrees each because they are equal. Some of the angles would be equal to 180. All right, so angles here, the angles are equal to 60 degrees. Let's label A, B, C. So that is the classification of our triangles. All right, let's quickly look at something peculiar about right angle triangle that we talked about earlier on here. Number 3, when it comes to angles. All right, a right angle triangle. Right angle triangle properties. All right, number 1. One of the angle is 90 degrees. Number 2. The side facing 90 degrees is the longest side of this triangle, is the longest side of this triangle, and it is known as the hypotenuse, and it is known as the hypotenuse. Right. Number 3. Then we talk about the theorem of Pythagoras, which says that the square of the longest side of a right angled triangle is equal to the sum of the square of the other 2 sides. All right, let's quickly check a diagram to see what we mean. So if I have this right angle triangle here, and I call this A, B, and C. Now this angle B is the 90 degrees, so this becomes my hypotenuse. It's the longest side. We can therefore say that the square of the hypotenuse AC squared will be the sum of the square of both sides, AB squared plus BC squared. And with this, we can manipulate to get which of the sides just by using our mathematical algebra. So AC squared is equal to AB squared plus BC squared. Don't forget that this angle, or the side rather, 1 is the longest side. 2, it is opposite the angle 90 degrees. That's very, very key. All right, we will then go ahead and deal with a few examples later on. Let's quickly look at another property when it comes to angles. Already we said the sum of the angles should be equal to 180 degrees. All right, angle property. Angle property of triangles. Okay, angle property of triangles. Let's draw a triangle. All right, and then I'm going to draw a straight line. There, beautiful. All right, my small note will be the sum, number one, sum of interior angles of a triangle is 180 degrees. A, B, C. I'll call this C1 and C2, and let's call that D. All right. Okay, so let's call this A1, B1. So in this case, what we are saying is A1, which is already A. There's no need to call that A1 anyway. A plus B plus C1 equals to what? 180 degrees. All right. Now, number two, I want us to check something here. C1 plus C2 would actually be equal to 180 degrees. All right. We talk about angles on a straight line. Okay. All right. C1 plus C2 would be 180 degrees. We talk about adjacent supplementary angles. That is property of a straight line. Adjacent supplementary angle. There is something we want to quickly see here. Angle. All right. Now, but check. I want us to check A1, A plus B. Just simply call it A plus B plus C. Now, if both of them are equal to 180, I will then say A plus B plus C1, which is 180, equals to C1 plus C2. And there it becomes negative and cancels out the C1. So A plus B, therefore, will be equal to C2. Ah, this is lovely. A plus B. Let's do this. Yellow one there. Let's put a blue one there. Now, both of them should be equal to that. So I'm going to use my color code to do that. So the sum of A and B. And in mathematics now, we say that the exterior angle, because it's outside, the exterior angle of a triangle is equal to the sum of, this is very important, opposite, all right, interior angles. There are two of them there. Sum of opposite interior angles. Very key point that we have mentioned here. All right, so please, these are things that we must not forget about the angle property of a triangle. Awesome. Now let's run quickly. All of these we've done before. Let's just remind ourselves quickly. Properties of straight lines. Properties of straight lines. All right. Now, we need to know, number one, we talk about vertically opposite angles when we have an X. So basically, we are saying that this angle here is equal to that angle, and so they are opposite. And this angle here is equal to that angle, vertically opposite angle. So I'm using my color codes. All right, number two. Or I can use the number. Let me use number in case it's in black and white. I have two dots here, which is also equal to that. All right. Number two. Number 2 is talking about our fan. All right, we talk about fan. All right, so if we look at the first one, so I'm just going to combine the three. But when we look at this, we need to talk about parallel lines. Okay, that line is very skewed. Okay, a bit better. All right, remember this has to do with parallel lines. Let me just clean that and write parallel lines here. And if lines are parallel, we use that arrow. It could be 1, it could be 2. All right, doesn't really matter. But if it's 1, then I use 1 on both lines that are parallel. All right, so we say that this angle here must be equal to that angle. All right, so when we talk about our F there, we talk about corresponding angles. So it looks like an F. So we talk about corresponding angles. Again, it's just a revision. This we already have. All right, here we talk about co-interior angle. All right, co-interior. So if I talk about A here and B here, we say co-interior angles are supplementary. So angle A plus angle B should be equal to 180 degrees. Co-interior angles are supplementary. Co-interior angles are supplementary. And here I'm going to talk about alternate angles. And basically we're saying this angle here is therefore equal to the inner angle. All right, so it gives you an N, and this is just what we refer to as your fan. All right, still on straight lines. That's number 2 there. Number 3. So if I have A, B, and C, all right, B1 and B2 are adjacent supplementary angles. And when we say they are adjacent supplementary angles, B1 plus B2 equals to 180. All right, and we talk about that because they have what you call a common M. Okay, that's very, very important. Now, number 4. If I have that A, B, C, B1 and B2, the first thing I see is that B equals to 90 degrees, which is a right angle because of the sign I'm given there. All right, so B1 plus B2 equals to 90 degrees. These are adjacent complementary. So let's get the difference between complementary and supplementary. All right, complementary is 90 degrees, supplementary is 180 degrees. All right, number 5 quickly. We can talk about A, B. Let me do this here. B1, B2, B3, C, and D. All right, so B1 plus B2 plus B3 would be equal to 360 because we talk about angles around a point. Angles around a point there. All right, so basically it's almost like saying we've got a circle there. All right, so it's basically saying we've got a circle. I actually wanted to see if I could draw that. Okay, all right. So basically we're saying we've got a circle. I'm just going to make it very thin. All right. So that point there gives me a small circle. I'm just making it big. All right. And that gives me, we know that the angle on a circle is 360. All right. So a circle is just a point that is enlarged. All right. And then we look at number 6, a bisector of angles. And when we say bisect, the word bisect means to divide into two. All right, bisect means to divide into two. I could then have this. A, B, all right, C, and D, B1, B2. If I'm given this, then I would say, remember the number of dots tells me that those angles are equal, then I will say BD bisects, all right, angle ABC. The angle symbol is on B. So we have A, B, and C. And the angle there between the lines AB and BC is B. So we talk about bisector. All right. So this is just a quick summary on lines, triangles. And the last section would be to quickly look at quadrilaterals. And the quadrilaterals, we should actually talk about 6 of them. All right, we talk about 6 of. Number 1, a parallelogram. One thing we should know about a parallelogram quickly. All right. I'm just going to make it concise and very brief here. So number 1 is a parallelogram. Opposite angles are equal. So if I do that, you should know now that opposite angles are equal. All right. And the symbol there, that arrow-like triangle, tells us that 2 pairs of opposite sides are parallel. 2 pairs of opposite sides, okay, are. So that means I could then have that and that. All right. 2 pair of opposite sides are what? Parallel. And we talk about the angles. All right. And the sides are not just parallel. They are also what? Equal. And how do we show the equal? This must be equal to that. One line, and that equal to that. All right. And don't forget the angles. Opposite angles are equal. And that's why I'm putting those dots there. Opposite angles are equal. Okay, number 2 is a rhombus. Let me write it first. And what is the trick here? when it comes to a rhombus. We can turn it around if you want. All right. The trick about a rhombus is this. Just like we said earlier on in point number 1, parallel, but now all the sides are equal. That is the difference there. All sides are equal. And again, opposite angles are also what? Equal. So take note of that special property of a rhombus. All the sides are what? Equal. All right. Also, very important, the interior, sum of the interior angles would be equal to 360. So let me just put a point here. Sum of interior angles is equal to 360. And the same thing applies here. So the only difference here, so I'm just going to write the difference only. All sides are equal. Number 3 is to look at a rectangle. And what do we know about a rectangle? I can get a rectangle from here. Lovely. All right. Again, like we've done earlier on, the sides are parallel and not just parallel. That is equal to that. But what is the difference between a parallelogram, the first one, and a rectangle? The angles here are 90 degrees. And since opposite angles are equal, it means that all the angles are 90 degrees. So all angles are 90 degrees, all right? Opposite sides are parallel and equal. So that's the basic difference. But interior angles again would sum up to 360 because 90, 90, 90, 90 would sum up to 360. All right. Number 4, a square. I'm sure we know what a square is. So if I talk about a square, these sides are not just parallel, they are all the sides are now equal. So I'm going to use one line there. All the sides are equal and all angles are equal to what? 90 degrees. So all sides are equal. All are also what? Equal. All right. And don't forget, opposite sides are parallel. Okay, in this case we can actually refer to them as adjacent sides as well. Adjacent sides are equal. All right, number 5, I said we have 6 of them. Number 5 is a trapezium. All right, so a trapezium is a quadrilateral with one pair of opposite sides. Just only one pair here are parallel and they're not even equal. All right, a trapezium is a quadrilateral with one pair of opposite sides parallel. Again, the interior angles would add up to what? 360. All the quadrilaterals, interior angles is equal to 360. So one pair of sides are parallel. They are not equal. All right. Number 6 is a kite. Okay. I'm going to have to draw this. Let's see. Oh, almost there. Let me do that again. Okay, fair enough. One more trial. Okay, I know how to get that done. I have an idea. Okay, now let me try again. All right. But it looks more like a rhombus. I don't want it to look like a rhombus. Okay, just need to quickly get that done. What I will do is I will shift this up a little bit. Awesome. I would get it now. Okay, fair enough. Let's delete that. I was using the property of diagonals to get that done. All right, so this is a kite. And one thing about the kite is that the adjacent sides are what? Equal. Adjacent sides of. So it's a quadrilateral, all right? Two pairs of adjacent sides are equal. Here there are no there's nothing parallel here. So you would see I've just used 1, 1 to talk about one line there, or stroke to talk about the equal sides. Okay, so we talk about two pairs of adjacent sides are equal. So these are the general properties of quadrilaterals. Not looking at their diagonals, just quickly looking at the basic properties. All right, so in the next lesson we will deal with a few questions, and then we would go to the main we will talk about the diagonals also in the next lesson, and go to congruency and a whole lot. So this first lesson is just bringing up us to speed, all right, about properties of triangles, all right, quadrilaterals and lines. Catch you in lesson number 2 with a few questions, a few activities, and how to deal with all our shapes. Goodbye.